Hello. Hey, dear viewers, let me know if you can hear me. Just hit in the comment section. And I appreciate. All right, let us invite others so that we can get started. So this is a math marathon. We are going to do a quick revision on some fundamental concept in foundational mathematics. Particularly, we will look at exam type questions. Okay. Let us keep on inviting others. All right, so we are going to get started. The first question that we're looking at is finding the derivative of this given function. So normally in an exam, they will tell you to find the value of the derivative at that given point, or sometimes they will say find the gradient at the given point. So our function, I will write here, our function y is equal to, this is e power 3x cosine 3x, okay? So as you can see that this is a product of two functions. So to find the derivative, we are going to use the product rule. So I will say dy dx. So note that dy dx is just the same as y prime. That is another way of denoting that. So I will write y prime is equal to u. So this is just uv prime, which is equal to u prime v plus uv prime. So since it is the product of two functions, we are going to take the derivative of one function, leave the other constant, then leave the first one constant and take the derivative of the other function. So in our case, we can say u is equal to e to the power 3x. Okay, so this implies that u prime, or the derivative of u, which is the derivative of the exponential function to the in 3x, is just the same as, so this is 3 e to the power 3x, right? So I believe you already know how to find the derivative of the exponential function. You can either check on the derivative table or use chain rule to take the derivative of that. So in the similar manner, we can say our v is equal to, so v is equal to cos 3x, so which implies that v prime, or the derivative of cosine 3x with respect to x, so this would just be the same as, so since this is cosine, it will be negative 3 outside, then sine 3x, in that order. Okay, so we have v prime, we have u prime, we also have v prime. Okay, so on this end, I will say therefore y prime is equal to, so the derivative of u, that is 3 e to the power 3x, and then we left cosine constant, so this is cos 3x. Okay, so since we have a negative here from the derivative, I will say minus, and we keep e to the power 3x constant and put our derivative here, which will be 3, and this is sine 3x, in that order. So that is the derivative. Now we have to evaluate this function at 0. So this is y prime at 0. So where there is x, I just put 0. So this is 3 e to the power 0. Then this will be just cos, that is 3 multiplied by 0, it will be just be 0. Then minus, I have 3 outside, e to the power 0, that is, well, I can just write 3 on 0. Then this is sine, 3 to the 3 multiplied by 0 to also be 0. But we know that sine 0 is equal to 0. So this end we have 0. So everything here gives us 0. And this will be equal to, that is 3. And the exponential function evaluated at 0, it's 1. And then cosine evaluated at 0, it's 1. So this is multiplied by 1. So everything will be 3. Okay, so that is how we compute the integral. All right, so let us look at the second question. All right, so I will go ahead and erase this part. Erase this part. Okay. So the second one, we want to find the definite integral. So by the fundamental theorem of calculus, if you have the integral of a from a to b of f of x dx, this is just the same as, so you find the antiderivative of this function, which we will call capital F, and evaluate it at b, minus capital F evaluated at a. So our task is to find this function f, okay, which is capital F, then evaluate at b, which is pi over 2, then subtract it by the value evaluated at 0. Okay, so since this is the product of two functions, we are going to use integration. We are going to use integration by parts. Okay, so integration by parts tells us to say, this is just a formula, the integral. I'll just use, so the integral of u dv, okay, the integral of u dv is just the same as u multiplied by v minus the integral of v du. Okay, so this is the formula. The integral of u dv is equal to u multiplied by v minus the integral of v du, that is the derivative of u. Now, the choice of u, you want to choose a u in such a way that if you differentiate it repeatedly, it vanishes. Okay, it vanishes to 0. Okay, you don't want to choose a u that when you take its derivative, you just be running around circles. So in this case, you can see that our choice of u will be equal to t. Okay, so let u be equal to t, and this implies that is the derivative of u. In other terms, I will say du with respect to t is equal to 1. Okay, so you can see that if I differentiate 1 again, I get 0, so it vanishes. So I can multiply throughout here. So this implies du is equal to dt. Very good. Next, we have our u is t, so the remaining part is our dv. So derivative of v is equal to cos t dt. Okay, now since we want v, we are going to take the integral of both sides. So the integral here and integral this side. So therefore, our v in this case will be equal to, you know, the integral of cosine is sine. So this will be sine t. Okay, so that is our v. So we have our u as t, we have du as dt, and we have v as sine t. So we can go ahead and substitute in our formula I will call star. Okay, so I will clean this part. You can take a snapshot and then we proceed. So I clean this part. All right, so let us call this integral as, maybe I can call it I. Okay, I'm just writing I because I don't want to rewrite the integral. So therefore, our I becomes, so we said we take u multiplied by v. Our u is t, so this will be t multiplied by v is sine t. So this will be sine t. Okay, then what next? The next thing is minus, right? So we say minus the integral of v, which is sine t. So this will be sine t. Then we said du, but our du is dt. So this will be dt. Okay, but remember, this is not an indefinite integral. because it has limits, but I'll just first of all take f. Okay, so what is this? So this is our t sine t minus, now the integral of sine is cosine, negative cosine, so this will be plus cos t. Okay, so actually I called this I, but I would have called it f. Okay, so if I call it f at t, right, so this is f at t, so this is capital F. Okay, now we are going to find f of b minus f of a. So what is f of b? That is f, capital F, evaluated at pi over 2, that is pi over 2. Okay, so what is this? This is equal to, this is pi over 2 sine pi over 2. Okay, then plus cos pi over 2. Okay, so what is this? So this is equal to, if you use your integral table, you realize that this gives you 0 and this gives you 1. So everything here is pi over 2. Okay, now we have f at 0, that is the lower limit. So f at 0 is equal to, so this is 0 multiplied by sine 0, then plus cosine 0. Okay, now what is this? So this already is 1. I mean, this is 0 and this is 1, so that is 1. Okay, so therefore the integral from 0 to pi over 2 of t cos t is equal to, so we said f at b, which is f pi over 2 minus that, but this is pi over 2 minus what? Minus 1. Minus 1. We end there. Okay, so if you want, you can write this as a single fraction. That is your choice. That is pi minus 2 over 2. But if you want, you can end here. That is pi over 2 minus 1. All right, so that was our second question. Let me look at the next question. All right, so the next question involves matrices. So I'm going to erase this part. I will erase this part, so you can check the image in the event. That is where the questions are posted. So we have been given that this involves matrices. We have been given that A is equal to, that is 3, 7, 5, and 2, and B is equal to negative 3, 4, 2, and negative 2. Okay, so we want to show or verify that A B transpose is equal to B transpose A transpose. Okay, so this is very simple again, because we're just finding the product of AB, then take its transpose, then show and see if it is equal to, if we first take the transpose of B and multiply it with the transpose of A. If this and this if the left side is equal to the left side, then we are done. Okay, so first of all, we have AB. Okay, so let's see. All right, so what is AB? So I will write this is 3, 7, then this is 5, 2, multiplied by what? I multiply by -3 minus my 4 and -2. -2 in that order. All right, so we can take the product. You can see that this is 3 multiplied by 3, which is -9. Then -9 plus, that is 20, right? That is 20. So this should give us 11. Okay, give us 11. Yeah, it will give us 11. Okay, so or maybe preferably I would write it, okay, so that you can see it. This is 3 multiplied by 3, then plus 5 multiplied by 4. Okay, that is this and that. Then this is 5 multiplied by 2. It will be plus sorry, yeah, this is 5 multiplied by 2. So this is, so I keep on repeating the same thing. That is 3 multiplied by 3 multiplied by 3 is that one, and 5 multiplied by 4. Okay, so the next we take 3 multiplied by 2 and then plus 5 multiplied by -2. Then we close here. Then 7 multiplied by -3, then 4 multiplied by 2. So 4 multiplied by 2. The order doesn't matter. So 7 multiplied by 2, then plus 2 multiplied by -2, and close there in that order. All right, so as I said earlier, so this is -9, this is 20, so this gives us +11. Okay, then next this is 6, and this is -10, so that should give us -4. Okay, then this is -21, and this is what? This is 8, right? So that is -21 and 8, so this should give us -13. Okay, so this is -13, and the next part is 7 multiplied by 2, which is 14, minus 4, which is 10. Okay, so hopefully you're following. Just see the notification. Okay, so that is the left side, that is AB transpose. AB, which is this one, then we take its transpose. Okay, so therefore AB transpose will be equal to, so I take the transpose of that. This is 11, -4, -13, okay, and 10. Okay, so that is what we have, and the next thing is to show that the right hand side gives us the same thing. All right, so I erase this. So I erase that. So what is B transpose? So first of all, okay, so I write B transpose. Okay, B transpose multiplied by B. So this is -3. I take the transpose, which is 2, and that is 4, and -2. Okay, so make sure you take the transpose of B. Then A transpose is, that is 3, 5, and 7, and 2. Okay, so you can see already here that this is -3 multiplied by 3, which is 9, then 4 multiplied by 5, which is 20, and if you take the sum, it will give you 11. Then -3 by 7, that is, so this gives you, that is, let's see again. So -3 and 7, that is -21, then 4 by 2, which is 8, and the difference is -13. Okay, then 2 by 3, which is 6, -2 by 5 is 10. So the difference is -4. Next is 4 by 2 by 7. 2 by 7 is 14, minus 4, that is -2 by this is 10. Okay, so you can see that our AB transpose is equal to B transpose that. So therefore, we have the given result. All right, so let us look at the next question. Okay, the next question is, so I'm going to erase here. You can just take a snapshot, then we continue. All right, so we want to show that 5n plus 5n minus 1 is divisible by 4. So we are going to prove this by using mathematical induction. So by mathematical induction. Okay, so basically mathematical induction has 3 steps. Okay, the first one is the base case, where n is equal to 1. Then we are going to use our hypothesis, then we conclude, right? So our task is just to show that we can write 5n minus 1 to be equal to 4 multiplied by q, where q is an integer. Okay, so this is what we want to prove. Okay, so very simple. Our first case is the base case. So step 1, when n is equal to 1. Okay, so look at the right side. So the right side is 5 power 1 minus 1, right? And this is equal to 5 minus 1, which is 4. Okay, and this is equal to 4q. Okay, so you can see that 4 is divided by 4. So this is true. Okay, that is true. Then our next step, that is step 2, we assume, right? So assume true for n is equal to k, which is greater than, let's say, greater than 1. So remember, k is just a natural number. So then we can write 5 as into the power k minus 1 is equal to, so if this statement is true when n is equal to k, then that means this number is divisible by 4, so we can write it as follows. We can write it like that. So let's write 4 multiplied by p. So I reserve q for a later stage. So 4 multiplied by p, where p is an integer. Okay, now our task is to, so step 3, our task is to verify, okay, is to verify or deduce that this is also going to be true when we add 1 to k. That is to verify that, I'll just say verify true for n is equal to k plus 1. Okay, that is 5k plus 1 minus 1 can be, so this is, that is, so 5 multiply 5 to the power k plus 1 minus 1 can be written as 4 to some number, say q. So this is what we want to verify. Okay, now using our assumption here, we are assuming that it is true for n is equal to k, so meaning that we can write our expression as 5 to the power k minus 1 is equal to 4p. So we are going to use this assumption because at the back of our mind we know that this is true. So right here I'll write I'll just write using 5 to the power k minus 1 is equal to 4p, right, where p is an integer. So what we do, we multiply throughout by 5 because what we want to see is k plus 1. So I multiply by 5 this side. So this is 5 to the power k minus 1 is equal to, I multiply by 5 this side, 5 multiplied by 4, okay, 4p. So I take 5 inside by the laws, distributive property, then the laws of indices. This is just same as 5. 5 has the power 1, so this is 5k plus 1, right? Then 5 multiplied by 1 is 5 is equal to, so this is 5 multiplied by 4p. So I am doing deliberately here not to expand for a specific reason. So now look at negative 5, right? I can write negative 5 as negative 1 minus 4 because we want our negative 1. So I can write negative 5 as negative 1 minus 4, okay? So what is this? This is just 5 to the power k plus 1 minus 1 minus 4. Where there is negative 5, I write minus 1 minus 4. And this is equal to 5 multiplied by 4p. Okay, so this is 5 multiplied by k plus 1. I mean 5 to the power k plus 1. Then minus 1. I add 4 both sides. So if I add 4, this is 0. And this is 4 plus 5 multiplied by 4p. Okay. Next, I factor out 4 this side. Remember, I want to write this number as 4 multiplied by something. So this is 5 to the power k minus plus 1. I mean k plus 1 minus 1 is equal to, I factor out 4, so 4 outside, right? So this is 1 plus this is 5p. Okay. Now, at this stage, you would want to remember that p is an integer. So I multiply p by a natural number, it will still be an integer. If I add 1, it will still be an integer. So we can write this as some number q. So therefore, 5 to the power k plus 1 minus 1 is equal to 4q, where q is an integer. Then we are done. So this is the end of proof. Okay. So you can take a snapshot and we are going to continue. All right, so that was a question on mathematical induction. So this side you can take a snapshot and we'll continue. So let's see our last question for today. So I erase this. All right, let's see, where's the marker? So find, let's see. Let's say determine the term independent of x in 2x power 2 plus 1 over 3 to the power 10. Okay, so that is our question. Want to find the term independent of x in the given question. All right, so we're going to use the concept of so hint by the general term. Okay, so that is what we are going to use. So the general term formula is given by TR plus 1 is equal to, so this is combination, that is 10 combination R, then A multiplied by A n minus R, then B to the power R. Okay, so that is B to the power R. Now our first task is to find R, right? Then if we find R, we can substitute it in that formula and then see what proceeds. Now, first of all, we would want to understand what it means to find the term independent of x. So independent of x, it means it is a term in this expansion, which does not have x. Okay, so for example, I'm just giving an example. This may be x power 5, maybe 4x power 5 plus maybe x power 3 plus, let's say maybe plus 100, then plus x, then just like that. So if you have a binomial expansion which has this kind of an expansion, just an example, so 100, because it has no variable x, we say this is a term independent of x. Okay, so let us proceed. So what is tr plus 1? So this is equal to the combination. So here I was supposed to write n, but we know that our n is 10. So this is 10. I write r here, and a is the first term. So our first term in this case is 2x to the power 2. Then what is n? N is 10 minus r. Remember, we are looking for our term, our number r. Then we are going to multiply by. So instead of writing 1 over x to the power 3, I just write x power negative 3, right? So I write x power negative 3. So this is just the same as x power negative 3, then multiply by r. Okay, so that is the general term. So the next thing is to expand, right? So this is c to the power 10. 10, that is 10 combination r. Okay, then I multiply by. So this is 2 multiplied by 10 minus r, that is using the laws of indices. Then this is multiplied by x. So this is 2 by 10 is 20 minus 2r. Okay, so I take 2 to the power 10 minus r, then multiply by x, 20 minus 2r. Then this is multiplied by, so this is x to the power negative 3r. Okay. Now, remember, this is the general term, right? Any term that you can find in this expansion can be expressed in this form. So if I want the first term, right, so we know that r is 0. Okay, so you just put 0 here and find the term. If I want 2, that is t2, okay, and I find this term. So since we are looking for the term that does not have x, meaning that the power or the coefficient, the variable has the power 0. Remember, if I said 100 is maybe an example of a term independent of x, we can write 100 to the power 0 because x to the power 0 is 1. Okay, so therefore, our term independent of x will be, that is x. I can combine these terms. So this is 20 minus 2r minus 3r, right? That is adding the sum. This should be equal to x to the power 0. Okay, that is a term independent of x. All right. Now this is x to the power what? This is 20 minus 5. 5r is equal to x to the power 0. So since the bases are the same, please, we do not cancel the bases. We just say the bases are the same. We equate the power. So this is 20 minus 5r is equal to 0, right? And this implies r is equal to what? R is equal to 4. All right. So therefore, in this formula, we are saying the term independent of x will be this term here, because everything here is x to the power 0. remember when r is 4, so this is 4, right? So this is 12, right? And this is 8, and when you take the sum, I mean, this is 20 minus 20, so this is 0, so everything here is 0. So we're going to compute this term. So that is C 10 combination R. Then we are going to multiply by 2 to the power 10 minus R. So this is the term that does not have x. But we know that R is 4, so I write 4 here, and I write 4 here, okay? So what is this? This is just the same as 10 factorial divided by, this is 4 factorial, and 10 minus 4 factorial. Okay, so I first of all just compute this one, then I'll multiply it by that. So this is 10 factorial divided by, this is 4 factorial, and this is 6 factorial. Okay, so what is this? So I can, so in other case you use calculator, in some cases they don't allow calculator, so I can write 10 as 10 multiplied by 9 multiplied by 8 multiplied by 7 multiplied by 6 factorial, so that it can cancel out with that. Then I say 4 by 3 by 2 by 1 multiplied by 6 factorial. So this and this goes, right? Like that. Then if you do your calculations here, you can just see here, let's say 2 here is 1, 2 there goes, I mean 4 here is 1, 4 here is 2, 2 and 2 goes, then 3 here is 1, 3 here is 3, so 3 by 7 is 21, by 10 is 210, okay? But remember we had this term here, okay? And this is, that is 2 to the power 6, okay? And this gives you 64. So therefore, our term we are looking for is T4 plus 1, which is just T5. So I can just write T5 here is equal to 210 multiplied by 64. That is what we are looking for. This should give you something like 13440. I think so. Let's check here. Yeah. So that is what this should give you. So this is how we find the term independent of x. So what is the hint? We use the general term formula, okay? Why did we not expand this binomial expansion? Because, you know, 10 to the power, I mean, to the power 10 is a very, very long expansion. So we just use the shortcut that is by the general term formula, which is this one, okay? So you just put your n, simplify, okay, bring all the terms that have x, then since it is independent of x, you are going to equate them to x power 0. That is what we did here. Then find r. After you find r, you just substitute in your expression here where there is r. So you can see that this and that will give you 0. You remain with t to the power 10 minus 4, and then compute that. This gives you this value. So we end here. Please let me know how you feel about this revision, if we should continue, and continue sharing to other people so that more can benefit. Otherwise, it's bye-bye for now.